This video describes how to use the formula for finding terms of a geometric sequence. Here's the formula. T sub n equals T sub 1 times r raised to the n minus 1. Now, it might be a good idea to start out with an example, so let's make one up. Suppose you have a list of numbers, that's a sequence, and the numbers are 4, 12, 36, 108, etc., etc., etc. And if you think about it a little bit, you can see that the pattern involved here is to take a term and multiply it by 3. And then if you continue term by term, you generate the sequence of numbers. Now, to become a little bit familiar with the notation, it's kind of obvious. The 4 is term number 1, so that's T sub 1. The value that you multiply by each time, that's referred to as the common ratio, and it has a value r equal to 3 in this example. Here is the first term, 4, second term, 12, third term, 36, fourth term, 108. Since it's the fourth term, n is equal to 4 for that specific term. And t sub 4, the fourth term, is equal to 108. So let's jump right into example A. If the first term of a geometric sequence is 6, so we know that that 6 is the very first term. The common ratio is 7. So let's put that in a different color. And it asks to find the value for the 11th term. So 11th term, and what we're trying to do is to find the value of the 11th term. So let's run back through that information and assign some symbols. The first term of a geometric sequence is 6. The common ratio, that's r, is 7, and what we're trying to find is the value of a term, and it happens to be the 11th term. That means that n equals 11, but what we're trying to find is the 11th term. So let's write the formula down. T sub n equals T sub 1 times r raised to the n minus 1, and let's fill in some details. What we're looking for is T 11, and that is going to be equal to T1, which happens to be 6, times r is in this case 7, raised to the 11 minus 1. And let's finish this up. T11 is equal to 6 times 7 raised to the 11 minus 1, which is raised to the 10th. So let's go to the calculator. 6 times 7 raised to the 10th. Very large number for an answer, but there it is. 169,485, 1494. And you can see that the members of a geometric sequence with r greater than 1, in this case 7, get large very quickly. Okay, let's erase all of that and move on to the second example. Now, this time, the problem is a little bit different, and let's go through the reading of the problem. If the 9th term, okay, 9th term, that's telling us something, of a geometric sequence is 1280, and the first term is 5, find the second, third, and fourth terms. So let's assign some symbols to all of that. If the ninth term is 1280, that's telling us that term number 9 is 1280. Let's put that in blue. And going back to the fact that it's the ninth term, that's telling us that n is equal to 9. The first term, so that's t sub 1, is 5. And it's kind of obvious that what we don't know in this problem is the common ratio. And if we know that, that will enable us to find the second, third, and fourth terms. So here's the formula. T sub n equals t1 times r to the n minus 1. Let's fill some information in. T sub n, oh yeah, that's t9. That's going to be the 1280. That's going to be equal to t1, that was the 5, times r. In this particular example, we don't know r, but we do know that that r is going to be raised to the n minus 1. So let's proceed and do the arithmetic. 1280 equals 5 times r to the 8th. Next step, 1280 divide by 5. That'll be equal to r to the 8th. And 1280 divided by 5 happens to be 256. And if you have a good knowledge of powers, you know that 256 equals r to the 8th has as a solution r equal to 2. But if you don't have that knowledge of powers, what you can do is take the 8th root of each side of the equation. So 8th root of 256 equals r. Now, on the calculator, you can get an 8th root by going to Math and choose option 5, x root, and you'll need to put outside of the radical symbol 8 and inside 256, and that's equal to 2. So we now know that the value of r is 2, which takes us back to the problem. We recall that t1 in this particular example was 5, and what we're asked to do is to find the second, third, and fourth terms. So we take t1, 5, multiply by 2 to get 10, multiply by 2 again to get 20, and multiply by 2 again to get 40. These are the second, third, and fourth terms.